What's up, everybody? This is Sebastian. And here it is. The Micro Coral Dev Board from Google has finally arrived. It came in this coral colored pouch, and it is indeed tiny. It does have a number of important features on board, so let's go over everything. Here you'll find a tiny onboard camera with the low resolution of 324 by 324 pixels, as well as the impressive Coral Edge TPU. There is even room for a digital microphone and a set of 2 buttons. The largest chip on board is the dual-core Cortex M7 and M4 in one package. The board communicates and is powered by a USB-C port. Some of us get excited by the large number of GPIO pins, digital as well as analog. It is interesting to see these tiny board-to-board connectors on the other side. But the most surprising part is that there are 4 LEDs on this board. Each of them, of course, serves a different purpose. Starting from the top, there is a camera LED, Edge TPU LED, the user LED, and the last one is the status LED. But wait, that's not all. If you spend a little bit more, you will also be able to get the dedicated Wi-Fi module, which comes in this nicely bluish pouch. This add-on module features an external antenna connector and the Wi-Fi itself. With these connectors, the Wi-Fi module snaps right onto the main board. From experience, I can tell you that this setup is pretty firm. It feels great, and as you can of course see, it's very tiny. Please consider supporting my channel, and the link to the Patreon is in the description. Only Patreons will get the deciding vote and early access to videos from only $5 per month. And yes, I think it was made in China. Okay, something that everybody was waiting for. Let's power up this little board. Google has set up a website on how to get started with the DevBoard Micro. Let me simply read what it says on this website. This page shows you how to set up the Coral DevBoard Micro, a microcontroller board that can run TensorFlow Lite models with acceleration on the Coral Edge TPU. With its onboard camera and microphone, this board provides a complete system for embedded machine learning applications. Even if you have no experience with microcontrollers, this page explains everything you need to know so you can compile applications and run them on the DevBoard Micro. Let's gather some stuff to make it work. And obviously we need the Coral DevBoard Micro. I'll be using a Linux computer with Python 3 installed on it already. And as you have seen, I used a USB-C cable to connect the board to my computer. And here comes the detailed description of the hardware that you're dealing with. But there is something new on the software side. The platform is based on free RTOS, and here comes the great news. It is compatible with the Arduino environment. There are 2 different ways to run your machine learning models. You can execute the TensorFlow Lite models either on the MCU or with the acceleration on the Edge TPU. In part number 3, we can learn from Google what happens when you boot your board for the first time. Booting it for the first time is pretty straightforward, and it is much easier than booting the regular Coral Dev board. You will see a green LED above the camera turn on, and then Aim the camera towards yourself. According to this description, you should see the green LED near the center of the board turn on when it is facing you, indicating that the person is detected. Well, this is just a theory. In my case, however, regardless of if I face the camera or not, the LED flickered on and off. So unless there is something terribly wrong with my face, the pre-uploaded sketch didn't do its job very well. So let's just move on and go to the step number 4. We are going to set up for free RTOS development. To begin with, let us update and upgrade everything. I have learned that with Google, it is better to use the older version of Ubuntu. And as you see, I am the fan of virtual environment. Okay, it all boils down to just copying each line and pasting it into the terminal. And unlike before, the setup script runs fairly quick. Oh, apparently I am running a version 3.16 instead of 3.18 or higher. After a little bit of research, I learned that removing the CMake altogether is the deal breaker. So let me show you. Removing CMake only removes the version 3.16, exposing the version underneath, which is the one that we need. And voila, suddenly we have a version 3.26. Okay, so now we have a green light to continue with our bash commands. And be patient again, soon to be over, but in my case it took 6 minutes, just over 6 minutes to finish. Let's check if our device is actually visible to the OS. Right now I have actually 2 Coral dev boards connected to the same laptop. That's why I see the Google incorporated signature twice in my terminal. With the help of the Flash Tool script, we will be flashing now the Detect Faces app onto the board. When the flashing completes, the board reboots and loads the app. And here we come with the face detection again. Hopefully it works better than the previous example. According to this script, flashing to the flash storage has completed and the device is restarting to execute your application. The green camera LED turns on to indicate the camera is on, and the white Edge TPU LED turns on to indicate that the Edge TPU is running. Just like before, we have to make sure our face is well lit, and then hold the board facing us with the USB port facing down, which actually turns out is pretty important for the detection. With positive identification, the green user LED should turn on when the camera identifies your face. As you move the camera toward and away from your face, you should notice this performs faster and more accurately than the first person detection demo. Remember when I told you that the angle is very important? The face gets detected only in one position, with the USB-C connector facing down. As I rotate the board, I'm also trying to have the camera pointing at my face. With a small modification, they let you change the rotation of the camera. You no longer have to keep the micro Coral dev board with the USB port facing down. You could also change the position of the board with the port facing the right or the left hand side. So let's try this out. To do that, we need to open the Detect Faces app in an editor and find and change one line of code. Here it is, the camera rotation. The angle 270 degrees has to be changed into 0. According to Google, flashing the app is going to take much less time, and the reason for that is that the TF light detection module doesn't need to be re-uploaded. Oh yeah, that was quicker. Knowing better from experience, I better replug the board. So, now it is the game of finding what angle that actually is. And since it's easier to rotate the board than my face around the board, that's what I'm gonna do. And no false positive recognition when the USB-C is pointing down. Now we simply must try the multi-core model cascading, which is the unique feature of the Dev Board Micro. Namely, it is its ability to transition between models running on the M4 core and models running on the M7 core and the Edge TPU. It is called multi-core model cascading because information cascades between models on each MCU core. And to demonstrate this, Google created an app that runs a person detection model on the M4, and when it detects a person, it starts a post-detection model that runs on the M7 with acceleration on the Edge TPU. And this is how you can try it. All we have to do is just flash a new app. Traditionally, the flashing takes a little bit of time. And here comes the Python app that shows what the camera currently shows. Well, since it is facing the desk, there is really nothing to be seen. But as soon as I pick it up, here comes the image of me with the pose detection. That's what the bluish dots are here for, to estimate the pose. Hello guys, it all works. Life is good again. And in the background you can see the frames per second counter, and it is all around 13 frames per second. I am trying to hide my face from the camera to see what's gonna happen, and soon after the module goes into the low power regime with a friendly message that no person has been detected. But all of that would be too pretty, of course, so something had to happen. And the module had crashed, and it's not gonna recognize me anymore. I've tried, but there was nothing else I could do but to close the terminal. So I've decided to see the results in a different way without the image through the serial ports USB. Earlier today I told you I have two devices, and this is the ACM one that I have to use right now. And Coral Micro Dev Board works again. It recognizes me and in an enigmatic way tries to estimate my pose. Apparently I adopt a pose either being 0 or 1. Well, this is where it crashes again. Not the greatest thing for demonstration purposes. But I'm patient and I'll start it again. So it seems that when I'm not around and the camera cannot see my face, it prints the person's score as a negative value. In some future episodes, I will look into the Arduino side of this microboard. Please consider supporting my channel, and the link to the Patreon is in the description. Only Patreons will get the deciding vote and early access to videos from only $5 per month. Thanks everyone, and see you soon again.